Hokie dokie. Welcome to this week's quick quiz lesson. In this video, we'll be covering some of the big ideas in 1524's quiz 3 in 15 minutes or less. Let's get started.
Formula sheet, formula sheet, formula sheet, formula sheet. Profit, revenue, cost, profit.
An important tip when approaching practice problems is to go ahead and look at the last sentence or question in the statement. In this problem, they're asking us to find the weekly profit. So what we want to do is use what they're asking for to sort of guide our process. They tell us to find profit, so we need to find profit. What is profit? Profit is revenue minus cost. What is revenue? Price times quantity. And then what is cost? Variable cost times quantity plus fixed cost. So all we have to do is find all this information in this statement. The quantity is 16. Each bobblehead will sell for $17. Whatever an item is selling for is its price. So that's the price we'll use in the revenue expression. The variable cost is $7. And we see that the fixed cost is $55.
So all we do is plug everything in, calculate revenue, calculate cost, and calculate profit.
Boop, 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 boop. In this problem, again, look at the last question in the statement. They ask, what is the monthly revenue? To find revenue, we will use price times quantity. So the way you want to think is, where is my price and where is my quantity? They say we're selling 200 tickets, so our quantity is 200. We're given this equation where P represents the price of the ticket. But in order to find that price, we have to input a quantity. And since we know the quantity is 200, we will just plug in 200 wherever we see Q. Just like that. Calculate the price, we get 288.6. Now with this price and with this quantity, we just multiply them together, we get 57,720. Pay close attention to curveballs they might throw at you. For instance, in this problem, they say it costs them 41% of the selling price to produce and sell each barbell rattle. In this problem, they're making you calculate your own variable cost. So, to find 41% of the selling price, we would just multiply 0.41 by 5. Additionally, in this problem, they're asking how many rattles must they sell to break even. Whenever they're asking for a quantity, they're not giving you any quantity to plug in to your equation. So where they say this 7,000 up here, this is negligible. You want to ignore this. They're almost putting it there to throw you off. If the question is asking for how many of something, they're asking you to find the quantity, which means you won't plug anything into the quantity in your revenue and cost expressions. And then again, to find where you break even, you are setting the profit equal to 0. In this problem, instead of asking where you break even, they're asking what's the quantity for which you actually earn a profit. In other words, what's the least quantity you can have to actually start earning a positive profit. So if you were to just find the quantity for which you break even, you might get 27. But if 27 is the quantity for which you break even, or for which the profit is equal to 0, have you earned a profit? You have not. Instead, if you add 1 to that and you get 28, producing and selling just one more smartphone will finally push you from a profit of 0 to a positive profit. In this problem, again, they're asking you for the quantity for which you break even, but in this case, they actually give you the profit equation. So the same rules apply. You'll want to set profit equal to 0, but in this case, you'll have to use the quadratic formula in order to solve for Q. This is the quadratic formula, and this is where A, B, and C will come from. Once you use the quadratic formula, what you'll get is 2 solutions, or 2 Q values, 120 and 380. But then you'll want to use the first statement where they say they can only produce and sell up to 250. Therefore, the larger number will be canceled out and you'll only be left with the smaller solution. In this problem, in the last sentence, they're still asking you to find the profit. So we can find the revenue like usual, but in this case, we won't find cost the same way. Typically, we'll use variable cost and fixed cost, but if they don't give us information about variable cost and fixed cost, we'll have to take another route. In this case, they tell us that the average cost is represented by this expression here. So in this case, we have to use the formula for cost that says cost is equal to average cost times quantity. And so we plug in the average cost expression and we leave Q as Q. Distribute and simplify, and then find your profit like you usually would. In this problem, still looking at that last question to guide our process, they're first asking us to find the profit. Once we find the profit function, our goal will be to solve for t. All of our same formulas to find profit will be the same here. The catch is that the price and the quantity are represented by weirder expressions than we're usually used to. But as long as we identify them accordingly, the process is still the same. Once you find your profit function, it'll be something of the form a times t squared plus b times t plus c. It's the form of a quadratic function, or a parabola. Whenever a is negative, which it will be in this case, we will have a parabola that's opening down, meaning that this function will have a maximum and not a minimum. And so if this curve represents our profit, and they're asking for the ticket price t, which is kind of like our x value in this case, where the profit will be at a max, our goal is to find the t value or the x value for which this function has its max, or where the vertex is. And so this is where that negative b divided by 2a will come into play. Once you find this t value for the location of the vertex or location of the max, you'll be done. In this problem, they tell us to write the cost as a linear function, and then find the cost of producing 1,200 lamps. So it may seem a little confusing to have to write cost as a linear function, but when we think about it, the cost function that we already know sort of is a linear function already. So really, all we need to do is find the variable cost and find the fixed cost. It's as if we've found the slope and the y-intercept. And once we have those two things, we will have a linear function. And then once we find that linear function, we will just plug in 1,200. Here's another problem that uses applications of linear functions. So in this case, what we want to do is write demand as a linear function. And then we want to write supply as a linear function. And then in order to find where there's neither a surplus nor shortage, we will set the two functions equal to one another. Price will be our x and donuts will be our y. For demand, we'll start by setting up two ordered pairs. They tell us they can give away 350 donuts for free. That gives us the ordered pair 0 and 350. And then they say the demand drops to 250 when the price is 25 cents. If we think about what we need for a linear function, we want to find the slope m and the y-intercept b. To find m, we'll use our slope formula.
y2 minus y1 divided by x2 minus x1.
As a result, we'll get -4. For the y-intercept, there's a cool trick about this one. If you think about any y-intercept on a graph, think of that ordered pair. What's the x value? 0. That's right. And so, in this case, if we're given the ordered pair 0, 350, then that y value of 350 is our y-intercept, and we can set up our equation. Y equals -4x plus 350. And now we repeat the process for finding supply. 150 donuts for free. For 50 cents each, they can supply 200 donuts. When finding the slope, we get 1, and finding the b value the same way, we get 150. Y equals 1x plus 150. Once we have these two equations, we just set them equal and then solve for x. Here's another problem where they are essentially giving you two ordered pairs. And then because they ask how fast is the profit changing, they're basically asking you to find a rate of change. We've mentioned before that rate of change is basically just a slope. And so in order to find the slope between 2 points, we do y2 minus y1 divided by x2 minus x1. And we get $17 over quantity, or in other words, $17 per unit. Because we got a positive 17, that's how we know it'll be an increase instead of a decrease. Another phrase to describe a rate of change of profit is marginal profit. So in this problem, because they asked how fast the profit was changing when 55 units were produced, we could come up with the equation marginal profit at 55 units equals 17. Kind of like we see in this problem. They tell us that the marginal profit at 610 units is 2.4, which means when the quantity is 610, the profit is increasing at a rate of $2.4 per unit, meaning that if we increase the quantity by 1 from 610 to 611, the profit would go up by $2.40. And that's exactly what they say in statement 2 here. So this is a true statement. As you can see, the phrase marginal isn't just for profit. It can also be used for cost and for revenue. A good statement to keep in mind when talking about marginal profit, marginal revenue, marginal cost, or really marginal anything is this. As Q increases by 1, or as the quantity increases by 1, whatever that anything is will change by that much. For example, if I told you that the marginal cost was -7, then the statement would read, as quantity increases by 1, the cost changes by -7. Or to be more specific, as quantity increases by 1, the cost will decrease by 7. In this problem, they ask you to approximate the cost of producing 203 units. All they give us is the cost and the marginal cost when the quantity is 200. When the quantity is 200, the cost is 1100, the marginal cost is 50. If we apply our statement for marginal cost, it'll read, as the quantity increases by 1, the cost will increase by 50. Meaning, if we increase the quantity from 200 to 201, the cost will change from 1100 to 1150. Well, if the units are going up from 200 to 203, then that means the cost is going to go up not by 50, but by 3 times 50. And as a result, 3 times 50 is equal to 150. 1100 plus 150 is equal to 1250.
Elasticity, yeah.
Typically, you'll see elasticity represented with this symbol that I'll call N. There aren't that many problems with elasticity on this quiz. However, it's important to know these formulas going forward because they'll stick with you the entire course. Like in this problem, they tell us that the elasticity is -0.33. First, we would use the criteria to determine whether this elasticity is inelastic, elastic, or unit elastic. And we do this by taking the absolute value of the elasticity. To take the absolute value of a negative number is just to make it positive. The absolute value of -0.33 is positive 0.33. And then compare it to 1. 0.33 is less than 1. We say that the demand is inelastic. We can eliminate option A and option B. Now, the nice thing about C and D is that their premise is the same for both. They're telling us that they're increasing the price by 1%. This is where this equation comes into play. All we have to do is solve for the percent change in demand. So plugging in what we know gives us this. And then to solve for percent change in demand, we just multiply that 1% to the left side. We find that the percent change in demand is -0.33%. In other words, there's going to be a decrease by 0.33% for the demand if we increase the price by 1%. Here's a similar problem. They give us the elasticity, and in this case, they give us two different prices. They give us an old price and a new price. I'll call them P1 and P2. Elasticity equals percent change in demand over percent change in price. The catch is we have to actually calculate the percent change in price. This is where the equation new minus old divided by old will come into play. Or if you prefer, we could see it as P2 minus P1 divided by P1. When we set this up, it'll be 9240 minus 88 all divided by 88. As a result, we get 0.05. And as a percentage, this is 5%. This is just the percent change in price. So now we'd plug this in to this equation with -2 as the elasticity and 5% as the percent change in price. When we multiply by 5% to the left side, we find that the percent change in demand is -10%. In other words, the demand will decrease by 10%. And for this last problem, I'll go ahead and tell you how to approach it, but I'll leave it for you to work on as a challenge. This is probably one of the harder questions in this quiz. Like always, let's look at the last question in the statement. What is the percent change in revenue for the bike shop? In order to find percent change in revenue, we know we're going to have to use this equation. Again, new minus old divided by old, or R2 minus R1 divided by R1, and then times 100, which then means we need to find an R1 and an R2. We know that revenue is price times quantity, which means we need a price 1 and a quantity 1, as well as a price 2 and a quantity 2. Let's plug in what we're given. Our first price is 200, the corresponding quantity is 500, the second price is 242, and the second quantity we don't know. So the whole goal of this problem is to solve for Q2. We have to find quantity 2, so we can then plug it in here, calculate both the old and the new revenue, and then plug them in here to find the percent change in revenue. If you enjoyed this video, go ahead and hit the like button. If you want to stay updated for more videos like this, go ahead and subscribe. If you want to connect with me or other students at the same course as you, join the Discord. That's all for this week's quick quiz lesson. I hope you learned something. See you next time.